Looking at section 4.3, example 7. So I've got the first one written up here. This is a product rule combined with the chain rule. This is the function that we have here. We're asked to find the derivative, dy dx. So product rule says take the derivative of the first one, that's the 2x, multiply it by the second one, that's the first part of it, plus the first function times the derivative of the second function. Well, that is going to, the second function itself is going to require the chain rule. The general power rule is a sort of an easy way to remember that for this type of function. We have a function raised to a power. So what do we do with this second function? We take the 5, we put it in front, we leave that function alone, we lower that by 1, and then we multiply by the derivative of the thing that's on the inside of the parentheses. So that's a 5 there. That 5 is coming from the derivative of 5x minus 1. Simplifying this, we can multiply the 5 and the 5, and we're going to get 25. And the rest of it basically just stays the same. So for the second part then, we're looking for, sorry about that, let me write down the function and then we'll take its derivative. So the function in part B is y is equal to 4x minus 1 to the third divided by x plus 3. Okay, so then the derivative of this is going to require both the quotient rule and the chain rule. So the quotient rule, remember, says low d high minus high d low. So the low function, x plus 3, d high, that's the derivative of the top function. That is going to require the chain rule. Top function is a function raised to a power. So the chain rule says take the 3, put it in front, leave the inner function alone, lower the power by 1, then multiply by the derivative of the thing that's within the parentheses. So that's going to give us a 4 there. Minus high d low, so that's 4x minus 1 to the third. The derivative of the bottom function is just 1. I'm just going to go ahead and write that so we see that we're using the quotient rule for this. And then remember also in the quotient rule we have to divide all this by the bottom function squared. Okay, so there we go. Now this can be simplified a bit. So what we can do, let's go ahead and combine what we can in the numerator. Remember, this is all multiplication, so multiplication is commutative. I can combine these in any way I need to. So this is 3 times 4 is going to give me 12, so I'll get 12. Then I'll get the x plus 3, and then the 4x minus 1 squared, and then minus the 4x minus 1 cubed, and then all this divided by the x plus 3 squared. And there's really, you could simplify this more, but there's not any point. I mean, this would require expanding that. This would be a nightmare to try to expand any of that. So we'll just leave it as that for our final answer for the derivative of the quotient function that we have here.